In the complex and high-stakes world of the valves industry, proper installation is absolutely critical. Valves are the unsung heroes of countless industrial processes, regulating the flow, pressure, and direction of fluids and gases in pipelines and machinery. Yet, as important as the hardware itself is, the clarity and precision of installation instructions can make the difference between flawless operations and costly, even catastrophic failures. Unfortunately, poor instructions are an all too common challenge. Ambiguity, poor translations, missing steps, or insufficiently detailed diagrams can lead even experienced technicians astray. For new hires or less experienced workers, this lack of clarity becomes even more dangerous. Mistakes in installation don't just affect the performance of a single valve. They can cause ripple effects throughout entire systems, leading to leaks, pressure drops, system inefficiencies, or worse. One of the most frequent mistakes arises from ambiguous torque specifications. When tightening bolts on a valve, precise torque is often needed to ensure a perfect seal. Under-tightening can cause leaks, while over-tightening can deform components or damage gaskets. If the instruction manual lacks clear torque values, or if those values are buried in densely packed technical jargon, installers are left to guess, increasing the risk of future problems. Additionally, unclear orientation instructions frequently lead to valves being installed backwards or at incorrect angles. Many valves are designed to control flow in a specific direction, marked by an arrow on the casing. If instructions do not emphasize this orientation or the markings aren't clearly referenced, it is easy for a valve to be installed in reverse. This error can disrupt system flow, compromise safety mechanisms, and force costly shutdowns to correct. Flange gasket selection is another area rife with errors due to poor guidance. Gaskets must be compatible with both the valve material and the fluids handled. If instructions are overly generic or fail to specify gasket type, installers may use the wrong gasket, resulting in leaks or chemical incompatibility. In high-pressure or corrosive environments, the consequences of these mistakes can escalate rapidly. Electrically actuated valves present their own set of challenges. Wiring diagrams in installation manuals are sometimes confusing or lack detail on connections, grounding requirements, or control system integration. Even minor miswiring can render expensive actuators inoperable, or worse, cause electrical hazards. Poor color coding, incomplete labeling, or diagrams that don't reflect real-world cable routing can leave installers guessing, a risk that simply shouldn't exist. Sometimes, instructions overlook the importance of pre-installation inspection. Valves can be damaged in transit or suffer from factory defects. If manuals don't clearly advise on inspection steps, checking for debris, confirming unobstructed movement, or inspecting for visible damage, then flawed valves may be installed and go undetected until failure occurs under load. Another common oversight is instruction on pressure testing after installation. Skipping or inadequately performing pressure tests can allow undetected leaks or weaknesses to persist in the system. Good manuals detail step-by-step test procedures, while poor ones skip this crucial verification, leaving risk in the pipeline. The root causes of these mistakes often trace back to the documentation process itself. Sometimes, technical writers are not engineers, and vital details can be lost in translation. In other cases, a manual may be updated piecemeal over the years, accumulating inconsistencies and obsolescence. Budgetary pressures may also limit the translation quality for international markets, leaving non-native speakers with imprecise guidance. Ultimately, the consequences of installation mistakes due to poor instructions in the valves industry are real and significant. Wasted time, increased maintenance, system downtime, environmental hazards, and, in some cases, safety incidents. The solution is not merely better engineering, but clearer, more user-focused documentation, enhanced with precise diagrams, step-by-step checklists, and thorough translations. Investing in better instructions is not just about reducing errors, it's about safeguarding investments, ensuring worker safety, and upholding the integrity of entire systems. In the world of valves, as in so many industries, success truly begins with clear, reliable guidance.